One method of entering your system information into ASAP is to use the ASAP scripting language. I'm going to start by opening up a new blank editor window within ASAP, and in this is where I would enter the commands. To help you get started with understanding the ASAP scripting language, we include a series of templates that define specific types of commands you might commonly use. We also have a basic template, which I'm going to start with, that goes through the basic system definition. So what we want to do first is clear out any information that might currently be stored in memory, define some basic units and wavelength information, any optical coding information, as well as any media definitions. Once we've got that housekeeping out of the way, we need to define our geometry, our source, perform ray trace, and then possibly some analysis. Let's set up a simple system that shows you how this works. ASAP is case sensitive, so I'm going to first simply define a mirror surface. I'm going to orient it along the z-axis at a z position of 0. You'll notice my command tips is giving me some information about one form of the plane command. I could get other information as well, but I'm just going to define a elliptical mirror of 10 millimeter half size. And now I need to make that an object. So now I have a mirror surface, and now what I'll do is put a detector just to capture some energy, although it obviously won't do anything since the mirror is a plane mirror. And I'll put it to the left of the mirror. Also make it the same size. But notice I named this mirror. I also need to tell ASAP about the optical properties. So I'm simply going to put an interface on this surface that has the coding I've defined above that we called reflect, and let ASAP know that the media on either side of this surface is air. So now I have a surface that's my mirror, and then I'm going to make another object, which will be my detector. Okay, and then if I wanted to define my source, again, I can go up to my templates, and if I select another template, it will put the information from that template where my cursor is currently positioned. So right now, let me look at a grid position. And what this is telling me is I have a grid rect at this position, at a z position of -10. The size is 2 millimeters squared with 11 by 11 rays traced, and then we moved it to a z position of -15. What this means is I would have a point source at this location, but I'd only start tracing the rays from this location, so we don't see all the other rays. Now these won't fit quite with the coordinate system I've selected, so what I'm going to do is make this a -9 just inside my detector, and I'm going to start looking at the rays at a z position of -5, and what we'll now do is just do a little bit of a ray trace. The 2 exclamation points indicate comments, but again, let's just run this file. And as we see, our rays are diverging from our source, which was actually located back here, reflecting off our mirror and being captured by our detector.